Cool. All right, up next, we have a panel on scaling and interoperability. The panel is hosted by Fredrik Harrysson. Fredrik is the CTO of Parity, and I will let Fred introduce the panelists. This is a superstar panel, so talking about something super important. Enjoy.
Thank you very much, Lane. Yeah, hopefully going to be talking about everyone's favorite topic, scaling. With us on the panel, we have Philip Stehlik, the CTO and co-founder of Centrifuge. We have Lefteris Karapetsas, who works for Brainbot and works on Raiden. And we have Igor Barinov, the co-founder of, or founder of POA Network. So why don't we start out by everyone just giving a short one-sentence introduction of what it is that you're working on. Igor, you can start.
Hi guys, my name is Igor. I'm from POA Network. POA is immediately available scalability solution for Ethereum ecosystem, and also the first EVM chain two-way pegged to Ethereum. So tokens can be transferred from Ethereum to POA and back. Yeah, that's me.
Hello, my name is Lefteris. I am the development lead for Raiden. Raiden is the payment channel network for Ethereum. Essentially, imagine the Lightning Network, how it would apply in Ethereum.
Hey, my name is Philip Stehlik. At Centrifuge, we deal with a lot of financial documents, namely invoices, purchase orders, and these kind of things, and helping large corporates to connect each other in a decentralized way and send that data around. So that's kind of like a state channel, how these documents are treated. So we do that off-chain. And then we have an on-chain component as well. So I'm actually a user more on that particular part of what you are working on.
So let's try to frame the problem a little bit. We're talking about scaling, and everyone sort of knows this, transaction per second metric, but what are maybe some of the more underappreciated problems of scaling? You seem eager to start.
Yeah, well, let's talk about Ethereum, right? Because the scaling problem are applicable for many blockchains, but in Ethereum, if you open Blockchain Explorer, you can see that all blocks are full, right? And there are multiple existing solutions for scaling sidechains, forks, and there are about 15 EVM-based networks out there. And if you open Blockchain Explorers for them, you can see that blocks are empty. On Classic, it's like 1 to 5% each block. And the question is why people don't use them. And I think the big problem with scalability is interoperability. So that's why we combine these two topics together. If you're a dApp developer on Ethereum and you cannot use your assets on another EVM network, it's a problem. And second problem is tooling. If you don't have Blockchain Explorer, if you don't have MetaMask and Vura and all tools you usually have on Ethereum mainnet, you will not use the scalability solutions. So that's what I think about undervalued problem in scalability.
So for the question is for problems that we don't consider in scaling.
Or some of the more maybe less talked about problems.
Okay. Well, I have a very technical view on these problems, and I would say that what we need right now is solutions that are deployed and work, first of all, and then we can define the more concrete problems after we see solutions that are working, just like Lightning has deployed in Bitcoin, and they have UX problems, they have problems with the topology of the network, but once we also do the same in Ethereum, then we can perhaps define some other problems. Right now, I think that the main problem is to actually have scaling solutions that are deployed and working in the Ethereum mainnet.
I think from our side, as a user who wants, or as an application developer who wants to launch the application to enterprises transacting a lot of documents with each other, we want to do that right now. We don't want to wait 2, 3, 5 years until the optimal scaling solution is out there. So I think the conversation that we have is what can we release today on mainnet, and maybe keeping some other things more centralized potentially, or on some other solution, and then migrate that over time once that is possible.
So I think that relates to my next question. I think a lot of people in the audience here are dApp developers or application developers in general, and they are looking to build something, but with the problems that we have today, how can we work around those problems to still build something useful?
We're working on sidechains, so we think sidechain is a great solution. It's you can play around with different settings of sidechain, and you can get the user experience that you expect from Ethereum mainnet, but you cannot get it because the scalability problem is not solved there. I think for sidechains we need to build tools and different forms of bridges, yeah, that's the most important part.
So for tooling today, we are, I'm biased because we are building the Radeon network, and we already have deployed it in the Robson Ethereum testnet and are planning for a soon to come mainnet release. So I would like to ask people if they would like to see tooling, try the Radeon network, test our API, because the API that is currently right now on the testnet will be the same that will be on the mainnet. So they can try to create dApps that utilize payment channels, and what they will create will also be usable when Radeon goes on the mainnet.
And if I think about dApp development and kind of the approach we're taking is putting only transactions on mainnet where it's actually worth paying a lot of money in order to have them there. So that might be high-value transactions, or it might be super important data that doesn't change that much. And then for us, at least, trying to release something today, like before you are on mainnet, is really finding workarounds for these other parts. And I know some people do batching, and then only doing one transaction with like a batch of things in there. I think Peepeth, for example, does that as one example. Yeah.
Add one more thought. Recently I saw a project called Portis. It's a web wallet. It's like a MetaMask, but embedded inside a web page. And the great thing about this wallet that it supports multiple chains, so you can connect this wallet to multiple chains. And if your dApp supports transactions on both networks, you can get advantages of, for example, having ERC721 on mainnet and operations on side chains. And that's, I think that's a great thing, and dApp developers should think about multi-chain transactions within one dApp.
Speaking of what dApp developers should think about, you mentioned this a little bit as well, trying to build on Raid and maybe on the testnet, but what should dApp developers today have in mind to make sure that what they're building is future-proof for the scaling solutions that will eventually come out?
Well, it's a good question. I think that the scaling solutions should think about dApps more than dApps developers think about scaling solutions. For example, we all like Solidity, and I think when we think about EVASM, we should have something where you can reuse existing libraries, security audits, all the stuff that we as dApp developers expect to get from EthereumNet on these new scalability solutions. But for when we thought about which parameters we should select for sidechains, we think, okay, should we have not 8 million gas, but 80 million gas? And this can bring more use cases, but on the other side, developers who deploy it on the network with more gas limit per block will be limited to deploy it back to Ethereum mainnet. So we think that scalability solutions like sidechains should think about what they're scaling Ethereum mainnet and give dApp developers this streamlined experience. Like you don't think about this. Like make it. Don't make us think about your infrastructure, right? Just let us make it.
Just I want to add to that is, as a dApp developer, I do have to think about it a little bit though. Like if I'm having most of my data on a sidechain, but I'm just saying whatever other platform I want to interact with only exists on main chain, like I have to somehow get my data around. So when you structure your dApp, like thinking about that, like what are the other projects that I might want to build on? When might they be on mainnet? And how can I move my tokens or my data back and forth? Because I think bridges will not be available for everything. I mean, for ERC20 tokens and so on, like you can move them around relatively easily, but it will not work for everything right out of the gates.
No, actually they will be available for everything. There's a concept called arbitrary message bridging, Parity is working on this, and POA is working on another implementation. And this approach will allow you to transfer any type of message between networks.
But not today. That's what
Yeah,
right?
it's well from POA it's available on today. I can show you. Yep.
Okay, awesome.
But isn't this a kind of centralized solution because you are having a sidechain that has authority nodes?
It's a good question. It's a different Sybil control mechanisms, right? There is a proof of work, proof of stake, POA, and then POA, where is a validator set with list of authorities, can be different way to add or remove validators. So there are centralized proof of authority networks, which we expect to get from financial institutions, where there is a DevOps who can add or remove validators, right? And there are POA networks with on-chain governance where validators decide themselves who are next validators. So you can think about this as a club of validators, but within this group, all validators are independent. So that's actually, that's how we were inspired by Kovan network almost 2 years ago, and decided to make public decentralized POA network. So that's.
Yeah, I understand, but it's a different trust model. That's what I want to say.
Yeah, different trust model.
So to the original question, I would like to add something. So the original question was how are DApp developers supposed to prepare right now in order to have applications that can work with scaling solutions that will come. So I can speak about payment channel systems. So for that, you have to think about how your DApp will work and what you want to put on off-chain payments. The only way that you can structure your DApp so that this can happen is to have no on-chain side effects from the payments, because essentially then payment channels make no sense. So you have to structure your DApp in a way that when you want to utilize payment channels, you just also keep the results of the payments and the ledger off-chain.
So speaking about the payment channel specifically, do you think that that's a solution that will be general, that any DApp should use, or do you think it's application specific and you sort of have to really think about this in advance if this is an architecture that you want to build around?
Yeah, there is no silver bullet for sure. So you have to have a DApp that deals with payments and results of those payments. More generalized solutions could be combinations of payment channels and other sidechains or Plasma. But as for pure payment channels, no, not every DApp will benefit from the existence of something like the RADA network. So you need to have a specific kind of application, like let's say paid APIs, for example, pay-per-view streaming, and things like that.
Any other comments to add?
About payment channels, yeah, that's application-specific use case, and it's good that when we can have it on Ethereum networks, it will be great to have it, right?
So the final thing I wanted to touch on, just on the dApp side, is the UX of some of these solutions. So obviously, if you're just dealing with one chain, the mainnet, like you said, you can have a wallet that just interacts with that. What are the UX problems that come from some of these scaling solutions?
Yeah, recently one game migrated from Ethereum to POA. It's a game of how to build a narco cartel called Dope Raider, and it's a high transaction amount per user. So for about 250 users per month, they created about 150,000 transactions, and it's I think it's the most advanced RPG game. So what they expected from the game, that block time should be less than on Ethereum, because when you have like 5 seconds block, you can get more smooth experience. So for example, waiting for a new block is important, right? But also having block time smaller, not only because you can put more transaction, but because you can have more smooth UX and UI. So that's important for them. Yeah, they're happy because now they understand, okay, if we migrated from Ethereum to POA, and next day we'll get a better scalability solution, for example, new network with better parameters, so less expensive computation, they can do it again. So they can switch from network to network. And they used Bridge to migrate ERC7 to 1 tokens. So they migrated characters from Ethereum mainnet to a sidechain and re-implemented smart contracts. And yeah, that's a streamlined process. So I think parameters of the network can affect UX of games. And we don't need to think about sub-second blocks. Because when people interact with games, they still have to approve transactions like, okay, I have to move, I have to pay, should I move, and so forth. But when you made this decision should be at the same time or quite or slightly less than time you spend to make this decision. Yeah, we don't need sub-second for this because we're still human and we're still slow, right? Yeah, that's from our experience from migrating games. And by the way, I think the games will be the big use case for upcoming blockchain scalability.
Yeah, so the UX issue is very, very interesting for payment channels because so the goal of payment channels ideally would be to be invisible so that the user or the dApp that uses it doesn't really have to be aware of the concept of what a channel is or God forbid, the settlement timeouts and all of the challenge, the time challenge scheme of the hash time lock transfers. So the biggest challenge that we are facing in any payment channel system is to hide this from the user in a way that the user just says, I want to transfer X amount of tokens from me to Charlie. And this can go through multiple hops, but the user shouldn't have to care at all about it. And also the concept of opening and closing channels should not be visible to the user. So we are trying to introduce something that we call a connection manager. So it automatically connects to a network, according to some rules, creates channels with a particular token network and then manages them. And then when the user wants to close and leave the token network, then it closes and goes through the challenge scheme. So how to do that so that the user doesn't have to care at all, and how to have proper UX interfaces that communicate this nicely to the user is the biggest challenge that we have faced in UX.
And how we try to abstract that complexity of what happens under the covers is we just provide a simple API, in our case, enterprises calling a REST API, and we abstract things like, okay, when is this document final, right? So different chains might actually have different finality, and these kind of things, so abstracting that away, so that for them, it doesn't really matter that much, so kind of
so that abstraction would be sort of a layer 2 solution on top of this multi-chain architecture.
In this case, it's much more the client that they would use to interact with what that chain is underneath. So let's say Alice wants to send an invoice to Bob, and she wants to make sure like that document exchange is anchored and verified and is just there forever. Then we just have a new status that says guaranteed, instead of saying, okay, block height is X, because it doesn't really mean that much to Alice.
So people usually draw this comparison between sort of speed and decentralization being on opposite ends of a spectrum. And Lefteris, you touched on this a little bit. In the sidechain model, usually like in a POA setup, the trust model changes. You go from having maybe a public proof of work network to having to trust authorities. What are some of the problems and challenges with that?
Trust authorities, I think it's a more complex problem. So first of all, we need to understand how we start the network, right? And usually it's called trusted ceremony, and where this is a part where we have most risks. And in POA type of network, usually there is a role who bootstrap the network, like first validator. We call him master of ceremonies, and this validator onboard first validators. And like, who is this master of ceremonies is very important when you bootstrap a new network, and also you should understand who are validators and what are like security model of these validators. For example, companies can change ownership, and when you onboard companies, today it can be company owned by one company or person, and tomorrow can be different. So that's why we decided to have individuals with staked identity as validators and create some instruments how we can prove that they're independent from each other, non-affiliated, so they're not relatives, not a part of one organization. So POA network is a US-based network, so all validators are US residents with no previous criminal record, which is also important. And after this ceremony conducted, so when first validators were onboarded, we gave on-chain governance to validators. So it's a part of consensus, and validators can vote in or vote out validators. So for example, POA first network started with 12 validators, and after they started to onboard and remove validators from the consensus. And at the moment, it's 21 validators. And there's some academic research from Cornell called Decentralization in Bitcoin and Ethereum, and there's a conclusion that a quorum system with 20 or more independent validators can achieve better decentralization consensus-wise than current Ethereum and Bitcoin network. So that's a security assumption. Network exists for 10 months already, and without any security risk problems and governance and all other artifacts of this POA network can be publicly observed and verified. And the biggest advantage of this type of consensus is that it's horizontally scalable. You can take the same contract, the same parity binary, the same audited infrastructure, and you can deploy it for your POA network. And you can think, okay, I don't want US validators, I want EU validators, or I want companies as validators, or whatever you want, right? And you can bootstrap the same network with same security assumptions, and it will be as secure as the original network. And that's what we cannot achieve with proof of work, and it's harder to achieve with proof of stake. So horizontal scalability of POA-based sidechains is the best achievements of POA protocol.
I would have to ask you to repeat the question.
Sorry, the question, what are some of the challenges in changing the trust model to this POA sort of sidechain model?
Yeah, so especially coming at it from an enterprise perspective, a lot of the conversations that we had with folks, they're asking us, oh, cool, you're doing that on Ethereum. Ethereum doesn't scale. Can we do this on Hyperledger? I was like, no, that's not what we do. And at least our belief is that we want to do this as on public infrastructure as much as possible. I think there's this thing of like, what's the maximum viable decentralization at a given point in time. And so for us, it would be perfectly fine that there are, for example, validators that are run by some of the members of the network who are voted in or out in some kind of way. But then in the end, we want to be as much on a completely decentralized infrastructure as we can. So when that is possible, we want to migrate towards that.
Yeah, I already mentioned that it's a different trust model, so I don't think I can say much more other than that. An interesting fact is that, I mean, observation basically. I just heard that everybody, all of the validators are in the US, you said?
Yeah, that's...
Doesn't that place the entire network under US jurisdiction?
Yeah, so that was the idea behind this, that we are using some existing trust mechanisms, and for example, having all validators in the same jurisdiction can protect token holders from collusion of validators, more or less. And well, if you live in the US, you understand that each state has its own law, right? And like for example, we like validators in POA are public notaries, so public notary regulated state by state. There is no like federal agency for public notaries who can revoke license from them, and so forth. So they're all in the same country. They're residents of the US, but participation as a minor in decentralized network is decriminalized since 2014 by FinCEN. So like you don't need to have a money transmitting license to create blocks in public networks. So there is well, you have to pay taxes from what you earn from the network. If you don't pay, okay, you can get problems. But otherwise, if you create blocks in decentralized network, it's totally legit business for validators.
I would love to add to that is that as a user of a network like yours, I mean, it would be up to me or my application to decide, is that a trust model that works for me? Maybe somebody running somewhere where they don't want anything to touch the US, then that might not be the network of choice, and they can deploy their own network and so on, but that would be on the user of the network then to decide
Yeah, and consensus only, what consensus gives us? It gives us agreement on a set of messages which are valid by the protocol, right? So these validators, they don't make decisions about smart contracts and transactions. They cannot modify your balance without breaking the whole system down, right? Well, so they're just helpers to help the network to operate.
I want to move on to a little bit of interoperability and touch on that as well. So what can dApp developers do today who want interoperability, who want to talk like to all these different services and blockchains?
Can I start? There are multiple perspectives. I mentioned multi-chain wallets, and Portis is a good example where you can use one wallet to operate with two chains without switching the network. It's from UI perspective, but and also when we think about dApp developers, usually dApp developers working for some companies which made some ICO before, and they have ERC20 token and ERC20 token located on Ethereum mainnet, right? So there are multiple approaches how you can bridge ERC20 token from network to network. For example, at POA we have ERC20 to ERC20 bridge, and ERC20 token can be moved from, but not the whole supply, but part of the supply can be moved from Ethereum to POA or other side chain, and can be used for computations on the chain. So we have a use case with Bancor when Bancor deployed their application on POA network, and we deployed a bridge for them, where any Bancor token holder can migrate their ERC20 token from Ethereum to POA and use it as a bridge token on POA network for computations. And they have different use cases, right? For example, they have a Bancor use case for mainnet and a specific use case for stable coins in Africa on POA network. So I think bridging tokens from network to network is what dApp developers can use now, and it's, from my perspective, it's undervalued yet, right? So it's available now. So this interoperability available, you can do it right now, right? But not many examples yet. So I hope so.
So the question was interoperability between what?
For example, if you're talking using Raiden, could you use Raiden to interoperate between, let's say, a POA sidechain and mainnet, or like, what are the tools available if you want to use these different scaling solutions? Or
so the question is interoperability between different scaling solutions, right?
Yes, and yeah.
Okay.
If you see a sidechain as a scaling solution.
Yeah, so I have a bit of a radical opinion there, because we have already also talked with the Lightning guys for this. I think there are so many potential scaling solutions right now that have so much work to do on their own in order to, so we are creating protocols, right? When you create a protocol, you have so many things to take into account from the latency to the security. So if you have not yet deployed, tested, and gotten feedback from such a protocol, you cannot really think of interoperability. You can talk about it, it sounds good in paper, but I don't think that we should think about interoperability at this point. First, let's create the scaling solutions that work, and then we can think about interoperability.
It works. I'll show you after the panel.
Sure.
It might work for ERC20 tokens, but it might not work for some of the other use cases. I mean, what you're helping with Polkadot, that's going to be really amazing once you get to that.
So obviously bridges is one type of interoperability, and bridges come with their own set of problems. One key problem is that it's hard to it's hard to build a generalized bridge that would, for instance, talk between Ethereum and Bitcoin, and Ethereum and another Ethereum network, or Ethereum and like a Plasma network. And
one of the main questions we've gotten is messages that work in Raiden and in Lightning. And so that would be a hell of a lot of work for very, very little gain.
I would just one thing to add as a dApp developer. I see a lot of people kind of going down the rabbit hole, like, oh, we need to do, and so on. So if I just want to develop a dApp, just focus on something that works today, because not everybody can solve the scaling solutions on the level that you are doing it.
So how important is interoperability between just tokens, like we were talking a little bit before, and generalized states? So if you have interoperability between tokens, you can build something like a decentralized exchange, but obviously that's just one use case. So on that scale, like what is the most important thing we can get?
When you say interoperability between tokens, you mean like token swaps?
Yeah, like between Bitcoin and Ethereum, let's say.
Because like one thing that we can do with Raiden is that we can just any ERC20, any token that is on Ethereum and is ERC20 compatible, we can just swap it atomically. So this interoperability, sure, we have. That's easy. But between other sidechains and scaling solutions, we haven't yet thought. But there is ways, perhaps.
Yeah, bridges, for example. I think tokens are important because during the last 2 years, many companies and teams promised that they will deliver dApps and they will deliver working software, and most likely they cannot do this on the current Ethereum mainnet, right? Because blocks are full, it's expensive, and so forth, right? So many problems, and this way they can deliver on sidechains or forks or new networks, EVM compatible networks, and bridge their existing token and deliver what they promised, right? That's very important for the ecosystem because if projects will start not to deliver, and this will be a major problem for the platform, right? Because we'll see decrease of adoption of the platform, and ICOs will be considered as scam because they cannot deliver and so forth. And the idea of arbitrary message bridging or generalized protocols is important for new types of applications, which we will see soon, right? When we will have this applications as soon as we can.
Yeah, I think baby steps is really kind of that we're taking as we go towards more generalized integrations.
So touching on sharding a little bit, that's obviously the scaling solution du jour and something that everyone is excited about. It's much further down the line, but you could see sharding as starting up a bunch of Ethereum networks and they all share the same security pool. In that world, like how do scaling solutions that we are looking at today change? For instance, will side chains even be necessary anymore?
Yeah, sidechains helping to build Ethereum tools, right? Because we cannot live, for example, without Blockchain Explorer. So at POA, we decided to build a full-featured Etherscan alternative for sidechains, forks, and shards. And when you think about, okay, we have shards, for example, they're developed tomorrow, right? How can we see transactions on the shards? So we need to build tools to observe transactions. We need to build new modification in other tools. And sidechains can help here by adapting their tools to these new shard models. And that's good when we're working in the same ecosystem, because even though we think like we can be competitors in some sense, we're within Ethereum ecosystem. We're not going to Tezos ecosystem, EOS, Definity, and other ecosystems. And I think that's natural that we have different view on the same scalability problems, but we can work together to move what we love together, right?
So you're saying sharding will solve all of the sidechain kind of different sidechains and just solve that together then? Because I think there will be different chains for different use cases, and not everything is going to be on Ethereum, even though I love Ethereum, but not the whole world is going to run on Ethereum at some point. So there will always be other chains that somehow need to communicate with each other.
Yeah, if you have a dApp on sidechain and you're happy with speed and price and so forth, and there's another solution, why do you need to move, right? It's like you deploy it on, I don't know, AWS, and Azure offers you something, right? But you think, okay, cost of moving all these operation expenses can be bigger than advantages I'll get. So I think if sidechains are good enough for dApps today and they're happy to work on them, they don't need sharding. But new apps can go to shards, and these applications will live in the same kind of Ethereum ecosystem, but with different view about where this application is running on. That's right.
So as far as token transfers are concerned and sharding, so sharding would require for transfers between shards, it would require cross-shard communication, I suppose. So I don't think that it will achieve the same results as payment channel systems in one chain. So perhaps combination of both would be what the future would look like.
I mean, so we were talking a little bit. You were talking about starting up sidechains for these dApps, but if if every dApp has their own sidechain, then we're obviously splitting the security across all of these, and the security overall will decrease because there's a finite amount of sort of security to secure chains. Isn't this a problem in that model if you're starting up a bunch of sidechains?
Well, I look at this as like internet, right? So internet is a bunch of autonomous network operated by humans, connected by routing protocols, and there are different type of security problems. But we don't feel like internet is not secure, right? We feel that it can be insecure in some sense, right? But the internet itself is quite stable, decentralized, working together. The same will be with sidechains and other chains working together. Just each part of this ecosystem should think about security. For example, when we launched the bridge in production, we had 4 security audits for smart contracts because we thought, okay, 1 is not enough, 2 is not enough, 3 is not enough. Okay, let's make 1 more. Plus, we audited parity bridge Rust code implementation, which we were based on, and we had legal review because interop usually can be considered as money transmitting if you don't think about this and implement everything you want. It can be money transmitting, so it should be regulated. So we had 6 audits for the bridge between 2 networks, and this bridge is working quite secure, and I know what problems can be. And I think if someone will launch the same bridge between, for example, Classic and Ethereum, I can say, okay, guys, this is secure, you can use it. There are some security assumptions about this bridge, who are validators, what are limits, quotas, and so forth. You should consider this. But overall, I think, yeah, that's fine because it's working. The same with POA sidechain. You deploy it, it's secure, it's proven, public honeypot. Anyone can hack it, but it's not hacked yet. And when you think about security of each individual part and you combine them together and people use them and they use same security assumptions, it's like commercial airlines, right? Yeah, you don't care about pilots because they have the same education. But yeah, shit happens.
What sidechains? I can't talk about the security of sidechains as we don't really use them at the moment.
Related to the same sort of question can relate to state channels, and there's a lot of talk about Plasma being sort of insecure in everyone withdraws model and this sort of thing. Do you think that these layer 2 solutions affect the security of the layer 1 solutions?
Affect? I mean, layer 2 definitely depends on layer 1 being working correctly and being secure. Of course, I always expect layer 2 to be less secure than layer 1. It's on its nature, it's more complicated protocols, and they are depending on yet another protocol. It would be impossible to have the same security. So for payment channels, we are trying to have the same guarantees. But when you start to combine it with other things like Plasma or Plasma or other sidechains, then you would have different trust models, and then the security adjusts to these trust models.
And as a developer, just making sure that you use whatever implementation that really fits your use case. And I think what you meant is affecting the layer 1 security is when you have an exit scenario and layer 1 gets clogged. Is that what you meant? Or,
I mean, that's one scenario in which case basically everyone kind of trusts this layer 2 solution, but because layer 1 couldn't really keep up, they might actually lose some money in that scenario. Yeah. So I just wanted to end on a final question on what is your own vision for scalability and interoperability? Do they necessarily go hand in hand? Like, is interoperability necessary for scalability, or can you have one without the other? And what do you see in the future?
Yeah, we can make our stuff super scalable, by just keeping a lot of things off Ethereum, but that's not really where we want to go, because we want to plug into the ecosystem of dApps and protocols and whatever there is on this awesome network. So for that, interoperability will come into play from there, just to get access to all of that.
Yeah, so I think that scalability will first have to prove itself through various implementations. Some will just not be used, some will not survive. Those that will survive then will have to become interoperable between each other, and that's the end vision, where the scaling solutions that end up being used by dApp developers will have to become interoperable. And then we will have the scalability problem solved.
Yeah. Well, it's not possible to have vertical solution for one network. So most likely will be multiple networks. And if you have something horizontal, you have to connect it. And that's why interoperability is inevitable, right? So we cannot have chains without communicating with each other. And I think that there are some problems that we've not thinking about. For example, when we think about transactions per second and compare them with each other, we need to think about where we store the data, right? Because when you have 1,000 transactions per second, for example, in Ethereum node, it will be more than 5 terabytes a year, and on each node. And when we have a high throughput application on sidechains, what we see, we know that, for example, a game with 250 monthly active users can create about 2,000 reads per second to APIs. So like new applications can create not only writes, but only a huge amount of reads. And if you remember, Joseph Lubin recently mentioned that they have enormous amount of reads on Infura. He compared it with Google, and I can agree that for us, transactions per second is not as important as distributed read to this database. Well, I think we, as a layer 1 solution, should work on scalability and interoperability and make experience of dApp developers pleasant. And we need more dApp developers. Just, you know, it's such a point where we have many networks, but we don't have enough dApp developers. Check state of dApps. You know, most popular game is 500 daily active users. It's just a baby numbers, right? So build games, guys.
All right. Thank you all very much for joining me on this panel.